So good morning, good afternoon, and good evening, everyone. Welcome to another webinar by DataPlatformGeeks. My name is Rohit, and I will be your host for today. And today's session is on Azure Machine Learning SDK. And our today's speaker is Parashar Shah from Microsoft Redmond. He's a senior program manager there. And I have Satya Ramesh with me, who will be helping us with the moderation of Q&A. So a lot of you already know about eDominant Systems, Data Platform Geeks, of which you all are a part of. We have the annual summit, Data Platform Summit under it. And we have SQLMaestros with a lot of brands under it, which I will talk about later. And Peopleware India and Expand SMERP. So the summit, the Data Platform Summit, which is Asia's only data and analytics conference on Microsoft Data Platform and open source. We concluded it in 2018. It was a 3-day conference from 9th to 11th, and pre-cons, 2 days of pre-cons on 7th and 8th. This time it happened at Radisson Blu, a 5-star property in Bangalore. So as you can see here, it was a phenomenal success. On the stage, you can see the Redmond team with the corporate vice president, Rohan Kumar. We had more than 900 people participating at the summit from over 16 countries and 300 plus companies. So we have already started working towards DPS 2019. This time it's going to be a 3-day conference again on August 22, 23, and 24, with 3 days of pre-conference this time on August 19th, 20, and 21st. So these are the official. This is the official website of Data Platform Summit. Satya will be putting it on the chat window, so you can all browse that. So why should you really care about the summit? So this is mostly for you. It is about reskilling and upskilling, and the deep technical content delivered by the world's best MCMs, the world Microsoft experts from all over the world. And it is also a great networking opportunity for you. You get to meet some amazing people and amazing personalities, and you can make connections for life. And the world's best infrastructure, of course, at Radisson Blu. And DPS involves the community, which means that we put up our sessions for voting before the summit, and you get to choose what you want to learn at the summit. And those are the sessions that are delivered by the speakers at the summit. And these sessions, goes without saying that these are highly curated content and disciplined execution. So we have opened the pre-registrations for DPS 2019. So you can go ahead and pre-register now. Satya will be putting down the link. And pre-registration does not mean that you're paying anything right now. It just means you're just showing your interest that you want to participate in the summit and post the launch. Yes, and a great news, we will be launch on Feb 2 in Bangalore. We have a full day event coming up, and it is going to be a multi-track event in Bangalore Microsoft office. So that will be our official launch for the summit. And at the launch, we will be giving you a discount code to all the pre-registered people, and all of you can use that discount code to get the lowest price for the summit for DPS 2019. So go ahead and pre-register yourself, and post Feb 2, you will get the discount code which you can use. So next step, evaluate Data Platform Summit. We have all the sessions for the last 4 years, 2015, 16, 17, and 18, all put up on our website. You can browse all our photos, videos, all the feedback, everything. So again, this is our official website, www.dps10.com. The DPG core team, Amit Bansal, the founder and president, Manohar Puna, we have the vice president, and the rest of them, Avnish, Vijay Reddy, Sandeep Pani, Prince Rastogi, Surbi Agarwal, Sakharam, and Devdatta Nath, all are regional mentors from all over India. And these are the eDominant teams from Kolkata and Bangalore. This was at the summit earlier this year. You can see the DPG core team and the eDominant team on the stage with Amit Bansal. Special thanks to Microsoft for supporting us in our community initiatives. And so why join DPG? You all are part of DPG already, so go ahead and access all the free videos, labs, and all our learning resources. I want to point out that we have come up with a new meetup model. So the new meetup model allows you to be, once you apply, allows you to be the regional mentor with Data Platform Geeks, and you will be able to host meetups in your own organization. So just get in touch with us, fill out the form, and our team will get in touch with you. And what's more, you get to speak at our events too. So if you have any questions, any technical question, you can reach out to the community at at our Facebook and LinkedIn groups. And also we are on mobile on the Telegram app. So the Satya will be putting on the links for that. And you can join us there. So, and we have the YouTube and mobile. So all our Data Platform Geeks webinars are recorded, and once a even including this one. So once the webinar is over, we will be putting up it on our website, and we will be sharing the link with you. So you can check out all of that on SQL Server Geeks YouTube channel, and we have a lot of SQL videos, free SQL videos on YouTube at SQLMaestros YouTube channel. So without any further delay, let's get started with the webinar. Over to you, Parashar.
Okay, are you able to hear me now?
Yes, Parashar, we can hear you perfectly.
Okay, cool. Let me share my screen. Do you want to continue? Yes. Good evening, everyone. My name is Parashar. I'm a senior program manager in the Azure Machine Learning team. I'm responsible for Azure Machine Learning SDK and Azure Databricks. So today, this is what the difference between classical and deep learning ML and how Azure Machine Learning can help you do end-to-end custom machine learning. I'll touch upon a little bit on Azure Databricks because that is one of the compute platforms that we use, and I'll be showing an end-to-end demo. Whatever demo I'm showing, these are available on GitHub, and I have all the links available at the end of the slide. So if you have any questions, let me know. I mean, someone will have to interrupt and see because the screen, I don't know whether it's able to show me if someone has any questions. So let's get started. I just want to quickly touch upon the major difference in terms of various machine learning jargons that we hear, right? So at an uber level, there is artificial intelligence. So the idea is basically making applications or devices which can mimic human brain. We are not there yet, but there is effort which is going on, and every day we hear some new innovation happening or some new a human parity kind of thing being achieved, be it in terms of speech, be it in terms of vision or other cognitive skills. So machine learning, the way we think of it, it's a sub branch of it, and within machine learning there is deep learning, right? So this is how we envision it. And at Azure Machine Learning, we don't differentiate in these the tools and the platforms that we develop essentially cater to anyone who is creating AI apps, right? And these could be developers who are using existing machine learning algorithms, or these could be data scientists who are actually developing this machine learning or deep learning models. Okay. When we talk about Azure AI, essentially we talk about three different pillars. One is bots and cognitive services, which are pre-trained AI. Which is on the left-hand side. The other is the knowledge mining, which is basically cognitive search, where essentially you have documents or images, and then you want to figure out that, okay, relation between these or make them searchable and things like that. And the one which we will focus today is this center pillar, which is essentially custom machine learning, where you can use the Azure Machine Learning service on top of different compute options like Azure Databricks for Spark, or even Azure Notebooks with AML compute. So we'll be going details into it, but I just wanted to give a highlight of what it is there. Now, when we look at Azure Machine Learning, the service itself, we think of this particular stack, right? So essentially, you start with having a business problem, right? So you are trying to solve a problem, and you figure out that, okay, I have this data available. I want to solve this problem, and I want to use machine learning now, or deep learning, whatever you want to call it. So I'll refer to it as machine learning in general. Okay, but the idea is that based on the use case, you figure out that, okay, should I look for something that is already available, or do I have to develop something from scratch, right, which is custom. So in Azure, we have 30 plus APIs. We call it as cognitive services. And these are across vision, speech, language, or search, and many others. So these have pre-trained AI. So we have trained it with publicly available data sets and then made it available for you to consume it out of the box. So in this case, which is the top layer here, the idea is that you send data and then you get a response back. So it's a basically HTTP request response kind of mechanism. And if you have a batch kind of a scenario, then that is also supported. But the idea is you do not have to write your own machine learning algorithm, but you can leverage the pre-trained algorithms that we have. And in some of these pre-trained algorithms, or we call it cognitive services, we allow you to customize these models as well without, again, having to write code, but just providing your own data. So we have something called custom vision, for example, where you upload an image data set, like say 100 images, and then you can actually customize even the pre-trained model. Again, this is without writing a single line of code. Now, in business scenarios, often it can happen that these pre-trained AIs may not help out of the box, right? So that is why we have custom AI, where you have your own domain-specific data. You want to control which algorithm you want to use, and then train your model and then deploy it either in the cloud or on a device or somewhere else, right? And that is what we call as custom AI, which is the bottom 4 blocks over here, where you start with a development environment. So this could be your PyCharm IDE, this could be essentially your VS Code, Jupyter notebooks, or even Azure Databricks notebooks. Now, I'll be referring to Azure Databricks multiple times, but I don't know how much you are familiar with it or how much you use it. But in case there are any specific questions around that, please let me know. But if you do not want to use Azure Databricks, that's also fine. Whatever I'm going to show you can work locally on your laptop and also in Azure Notebooks or any other Jupyter or a Python environment. Okay? So you start with picking up an environment in terms of what your team is comfortable using. Then you figure out that, okay, which framework you want to use. So if it's a, say, for example, classical machine learning scenario, you might start with scikit-learn or any other framework which are there in classical machine learning. If it's a deep learning scenario, then you might start with something like TensorFlow or PyTorch. Again, these are open source projects, and Azure Machine Learning Service doesn't compete with any of these frameworks. So the idea is you can use whichever framework that your team is using, right, in an IDE of your choice, and still leverage all the benefits of Azure Machine Learning Service. And I'll talk about what are the features or capabilities which the service provides. Right? Now, this is the training framework, right? So you train a machine learning model with one of these frameworks. And then we also have something called Onyx, which I'll touch upon later, where essentially it's Open Neural Network Exchange. It's again an open source project. And when you train models with one of these frameworks, you essentially can convert it into an Onyx format, which is a common format, and then deploy it. And we'll discuss it further later. Now, in terms of the services, right? So Azure Databricks is, so think of it this way, that if you decide to use Spark, then Azure Databricks is one of the go-to options that you have. Of course, there are other options. You can even have your own on-prem or own Spark cluster, but then the Azure Databricks itself brings you the benefit of a managed Spark instance, right? So it's a distributed computing scenario. Now, if you do not use Spark, then still you can use machine learning VMs or something what we call as Azure Machine Learning Compute. And these are basically pure Python scenarios. Okay. Now, if you have scenarios where you are using R, then you could use something called data science virtual machine, and I'll touch upon it later. But central to all these is the Azure Machine Learning Service, which essentially allows you to do end-to-end machine learning. And we'll see in the demo as well that what I mean by end-to-end. So basically it's data preparation, training, and deployment. The final piece over here, it's the infrastructure. Right? So essentially now, not everyone has a very powerful laptop or a desktop. So when you are using a lot of compute, then essentially your infrastructure may not scale. And that is where you can leverage the power of Azure. So Azure Machine Learning Service itself makes it very easy to scale your training experiments or even your deployment, the machine learning web service which is deployed. So you don't have to worry about what hardware I will use and things like that. You can just submit a training experiment or pre-processing task or whatever you have, and then the infrastructure or the compute will scale automatically and then scale down once the training is completed. And we support options of CPU, GPU, and even FPGA for deployment. Okay. Are there any questions on this? I'll just pause for a minute. I don't know where to see the questions. Chat. Is it? Can we use Node.js? So is the question to me? Yeah. So Node.js basically, when you look at machine learning itself, right? Python is the most common language that is used over here. So if you are asking whether can I use Node.js for machine learning training, the answer is no, because I don't know of scenarios where someone is using Node.js. But there is JavaScript which is used, but that is more in terms of the inferencing part. So that you can use because essentially you are calling a machine learning model as a web service, and in that you can use Node.js. But that is post deployment, right? So here the scenarios which I'm talking about are training, where you use Python, and then once you deploy your machine learning model as a web service, then you can use Node.js, you can use Java, you can use C++, Python, Ruby, whichever language you want to use, basically, because it's a web service. It's an HTTP or an HTTPS endpoint, which you would call. So basically you send the data, get the response, and then you are free to do whatever you want to do with the data. So Azure Machine Learning itself doesn't restrict you from doing anything. Okay. Are there any other questions? Is there a question? I'll just unmute it. No. Okay. Moving on to the next slide. So the way we think of scenarios in teams are, there are two basic categories or personas that we have seen. So one is an individual development environment or an individual data scientist, and he or she is basically doing everything by going through data preparation, the cleaning up of data, basically creating features, training machine learning model, and then deploying it as a web service, for example, to actually consume the machine learning model, right? But in this scenario, the person is working individually and actually not sharing any of the components with some other team member. So in that case, a machine learning VM can definitely help. And this is basically a single user scenario, right? But then there can be scenarios, and which is more common in terms of how startups or even enterprises are working, is you have a team-based environment. So essentially, just like developers share their code and they collectively work, and there is DevOps and things like that. Similar to that, with machine learning, we are seeing that past few years that the collaboration component is increasing significantly because the projects are becoming more and more complicated, right? So someone is training one machine learning model, user B is training another machine learning model, and then eventually they stitch together these machine learning models in a pipeline. Or even the data source which is there, it is basically shared across different data scientists. So in this case, one of the options that, or one of the recommendations that we have is using Azure Machine Learning Service on top of Azure Databricks, right? So Azure Databricks provides you with a collaborative environment where you are having notebooks running. You can easily share this, do code reviews, share the compute infrastructure, and then the Azure Machine Learning Service itself works on top of Azure Databricks with a framework of your choice. So you can use Spark ML, or you could use TensorFlow, you could use scikit-learn, whatever you want to, and then actually create a model and then deploy it as a web service, right? So these are the way we think of it. But then, of course, you have the freedom. So in case you are using any other Python environment where you are doing collaboration, like sharing like Jupyter or things like that, you are free to use Azure Machine Learning Service on top of it, and there are no restrictions or limitations in that scenario as well. So the idea behind Azure Machine Learning Service is like boost the productivity of a data scientist in terms of like simplifying the tracking and run history monitoring of experiments, right? Increase the rate of experimentation. So basically, you are submitting your experiments to a cloud-based compute, so and which can scale automatically. You do not have to create the environment, like we create the environment for you. It's all Dockerized, it's based on Conda and all those things, so you have the flexibility of bringing in your own libraries, or even customizing version and things like that. And then once you are ready, that okay, you are satisfied with your machine learning model, then you are actually deploying it to the cloud, right? And then once it's deployed to the cloud, you can essentially even monitor the model, maintain different versions. Like we support up to 10,000 versions in a single workspace. And I'll tell more about what is a workspace basically. But we don't restrict you in terms of how many models you have or how many versions of different models you want to have. And then you can pick and choose which model actually is doing the prediction for you. Okay. Now, in terms of there are supporting capabilities. So we have a very powerful feature or capability called automated machine learning. And the idea, and I'll share more details later, but the idea is even enhance the productivity of a data scientist. So we are not trying to replace the data scientist, but actually simplify the search for algorithms and parameter tuning for a data scientist. All the compute that is used for training and deployment, the service itself manages it in your own Azure subscription. So essentially you have visibility in terms of how much you are paying for it, and also at the same time you don't have to worry about managing it. So there is an SLA which is associated, and we also give you the latest versions because a lot of things are open source based and it's on Linux. So that is also an option. And then you can have your own DevOps cycle around it. And then the deployment part, which I already touched upon. Now, the Azure Machine Learning Service itself can be consumed as an SDK. So the way you would install a Python SDK, like do a pip install. So pip install the Azure Machine Learning SDK, and it is available in your environment in a minute. But we also have other endpoints, like there is an Azure portal, which is there. So in your own subscription, you have that. And we also have CLI. So if you want to use command line interface, then we support that as well. So all these things are API based. And of course, all the open source frameworks are supported. So like I said, this is not an alternative to TensorFlow or scikit-learn or whatever framework you are using. It actually augments it. So you install these frameworks on top of the service, and then that's how you use it to increase it. Are there any questions right now? Just pause. No questions. Okay. Is my speed okay? Oh, there's a question. Is my speed okay? Everything? Okay. Can we provide data via different sources to AI web services? Yes. So essentially, again, just like we allow you to use a framework of your choice, you can bring in data from anywhere, be it Azure Blob Storage, SQL Server, Azure Data Lake Store, or even any other data source as long as there is a Python connector to it. So we don't restrict you from where you can bring in your data. And there is no restriction in terms of the size. So I don't know how many of you know Azure Machine Learning Studio, which was our first offering for machine learning since 2015 or so. But this is a parallel service to it. So Machine Learning Studio is still there, right? But it is targeted towards very small or citizen data scientists who are working on small experiments. But then when you want to scale it, it has certain limitations. Whereas there are no such limitations with the Azure Machine Learning Service. Like you can bring in terabytes or petabytes of data, how much ever you have. You can scale the compute associated with it based on how much your subscription allows, and you have all the flexibility. Okay. So are there any other questions? Okay, no. Okay, so a little bit on Databricks. So essentially, the idea here is that if you are using Spark, then you don't have to worry about managing Spark. Azure does it for you. And you with Databricks, you get a notebooks environment out of the box. So your team can collaborate. You have a auto-scalable cluster which is available. It's a Spark cluster, right? So it provides you the Python or a PySpark environment out of the box. And then you get all the benefits of Spark, basically all the distributed computing scenarios that you have. And then you can actually create pipelines, you can schedule your notebooks, you can integrate to the data sources in Azure or even outside of Azure. You integrate it with Azure AD, so the authentication and all those things are taken care out of the box. The deployment happens in a VNet, so the security stuff is also taken care. And then it integrates with Azure offerings like Power BI and even other things. So it's relatively easy to start with Databricks and then also install Azure Machine Learning Service on top of it. Now, similar offering we have are Azure Notebooks, and I'll show you the same during the demo. Right. Now, a little bit word on the data science virtual machine. I assume you have already tried it because it's been there for almost 3 years now. And the Azure Machine Learning Service is available out of the box. It's pre-installed in the data science virtual machine. But the way we envision data science virtual machine is scenarios when users actually are using a solo environment, but when they want to do collaboration, then either they will use something around Jupyter and probably configure things, or Azure Notebooks, or Databricks. So that's how it is. And otherwise, there are no restrictions. Again, this data science virtual machine, you can it comes with pre-installed frameworks and tools and development environments, essentially, and you can pick and choose which compute you want, how many CPU cores you need, whether you need GPU or things like that. So it's basically an image which is again Windows and Linux, and then you can even install certain things on top of it, and we maintain this. Basically, we test it for compatibility and release new updates often. So the idea behind this is, like, if something takes 2 weeks for you to create an environment, in this case, in less than 15 minutes, you have an environment up and running, which already has everything available. Okay. A little bit word on automated machine learning. Like, as a data scientist, and after this, I'll jump into the demo. So as a data scientist, like, think of the scenario on a day-to-day basis, right? What you do, essentially, okay, there's a question. So let me take the question first. Can we provide data via different, okay. So AI web services support only HTTP protocol or any other protocol. So the AI web service supports HTTP and HTTPS. Okay, so because we create a Docker environment for you and then deploy the web service on top of it. But it can be deployed in edge devices, right? Because as long as this edge devices are running Docker. As a data scientist, what you would be doing is essentially like have your data available, and then look at. So basically, you start with a problem, right? Basically, are you trying to do classification? Are you trying to do regression, or things like that? And then once you have your problem defined, you try to find out that do you have the necessary amount of data, or is it sufficient, or do you need to go and collect more data? Right? After you get the data, you try to clean it up. Basically, are there any missing values? Are there any like out of bound values? Like, is there any skew in the data? Then you also look at converting the data. So like, say, most machine learning algorithms require numbers. So if you have strings, then essentially you vectorize it and things like that. So this is basically what we call as data pre-processing, right? Then you create features out of it. Once you have features available, uh, which are essentially used to train your machine learning model, then you create the machine learning model. You do multiple iterations. So you might be happy with like a particular model, but if new data comes in, then you have to again retrain. So this whole process is very iterative, right? It's very repetitive, that you have to keep on trying, and then it is not that you do it once and it's going to work all the time, right? As and when you get new data, you have to again train your machine learning algorithms so that whichever metric you are following, so be it accuracy, or be it mean square error, or things like that, then that is within the threshold that you want. Right? So the idea behind automated machine learning is to simplify this. So you give us the data, you specify the type of problem that you are facing, and then we take care of featureizing, not featureizing, but pre-processing. So you still give us data in the form of features right now. So we pre-process it, so take care of missing values and things like that in your feature data set, and then we find the best algorithm for you. So you don't have to individually look at, okay, try logistic regression or gradient boosted or some other decision tree algorithm or something like that. We take care of going through all the different algorithms which are there, and then we optimize the parameters within that algorithm, and then we give you the best pipeline or the best algorithm that is suitable for your data set based on the problem you are trying to solve. And this is not like a black box, like whatever training we do, that is available for you to look at, like what happened in the process, and then you can actually even further optimize it if you want to. So that's the idea behind automated machine learning. And like I said earlier, we are not trying to replace the data scientist, but actually augment the flow. So I work with customers all the time, and one of the customers, they had a scenario where they are trying to do predictive maintenance, and they had a machine learning model, data scientist working with it, and it took like 3 months to develop. It gave a certain accuracy, and then we brought in automated machine learning, and in less than 2 weeks we were able to get a comparable model, right? And the good thing now is that anytime new data comes in, they can just rerun this pipeline, and if instead of this algorithm, if some other algorithm works better, then the customer gets that new algorithm automatically. Like, you don't have to change the code in terms of trying to change the parameters which are there or things like that. So the idea is to augment the flow of a data scientist, because you still need to understand what is happening. I mean, it's optional, of course, that because you are actually not trying to find out how does random forest work or logistic regression work. But then if we give you an algorithm which is something like, say, KNN or ensemble or any other output for the pipeline, if you want to know that, okay, what is happening, you can still look at it, but it's optional. But that's the idea. So with automated machine learning, we are targeting different audiences over here. So these are basically AI developers who may not know machine learning but want to do a quick machine learning. Of course, we are targeting data scientists because it is augmenting their flow and not replacing it. And then we are also targeting business analysts who are very good with data, and then they want to come up with something quickly out of the box. Okay. So that's on automated this thing. We already touched upon the open source frameworks. I'll just briefly mention Onyx. So this is an open source initiative. So once you have a machine learning model which is trained and available to use, what we saw is that if you have multiple frameworks being used, then there is a problem that when you're building a pipeline or a repetitive workflow, then you need to have all these frameworks available in the runtime, in the deployment runtime. So Onyx is what we launched last week, and it's a collaborative project with Amazon, Facebook, NVIDIA, many others, as you can see on the slide as well. And the idea behind Onyx is like you can convert the models which are trained using these open source frameworks to Onyx. So it's a single runtime that you have to maintain. So you don't have to worry about like, okay, I have one model which is trained with TensorFlow, another which is trained in scikit-learn. How will I combine these two? Like, do I need two different libraries installed in my deployment environment? You don't have to worry about that. And Onyx even works on mobiles. And basically, it's an Onyx runtime which you install. It also works on Windows laptops or any Windows device. Basically any Linux environment as well. So are there any questions? No. Okay. So that's about Onyx. Let's go to deployment and as part of the demo itself, right? So here, I assume everyone has an Azure subscription. If not, you can just search for Azure subscription and then actually yeah, so this is the help file, but you can actually go to Azure trial, right? So if you're not, you can try it out, but I encourage you to at least have an Azure subscription, because whatever I'm trying to show you right now will need an Azure subscription. So we have multiple options. If you don't have it, you can try it out with an Azure subscription. Okay, but once you have the Azure subscription available, this is something what you will see, which is basically the Azure portal from where you can create this Azure services. So the first thing which I'm creating is an Azure Databricks workspace or Databricks. But if you don't want to use Databricks, then you can also use notebooks, right? So it's essentially Azure notebooks which are there, and these notebooks also help you get started with data science quickly and out of the box, right? So you just do a sign in, and here you can use your organization email or your personal email, doesn't matter. And this can be different from your Azure subscription email as well. So both are independent of each other. But assuming that you already have an Azure subscription and you essentially log in with that, then the first thing you would do is create a Azure Databricks cluster. And to do that, you have to create an Azure Databricks workspace. Now, you will hear this term workspace multiple times. There is an Azure Databricks workspace, and then there is Azure Machine Learning workspace. So these are two different workspaces. But the idea behind workspace is that you can combine the resources which you are using in a single place. So managing it is easier. And then you can pick and choose which region or the type of pricing tier you want to use, right? So it doesn't take more than 30 seconds to create this workspace, right? And whichever region you create this particular workspace, that's where your cluster will be there. So assuming that most of you are in India, you can pick South India, Central India, or West India. So there are 3 Azure regions which are available, or even Southeast Asia. Like a lot of customers I work with in India, they use Southeast Asia as the region. But you can also use East US too and West US, because I personally haven't seen a lot of latency issues associated with it. So it's not a big problem if you use any of these. Okay, so once you have created this Azure Databricks workspace, you can launch this, and then you will see something like, once let it come up. Meanwhile, are there any questions? No. Okay. So this is what you will see over here. So this is basically a workspace homepage, right? And then the first thing you would do is to create a cluster. So you go here and you say create a cluster, and then you give a cluster name, right? So you give a cluster name, you select the mode. High concurrency cluster is something that multiple users can share without obstructing each other. And standard cluster is something which is dedicated to a user. Then you can essentially use different runtime, right? So we support Python 3. We don't support Python 2, we support Python 3, and then we support any non-machine learning runtime, because we are providing the machine learning service, so you do not have to use the ML runtime which is there. So if you want to use the latest version of Spark, you can do that, or if you want to use a previous version of Spark, you can do that. We don't restrict it, right? So that is there. The other option is auto scaling, right? So when you say auto scaling, then you can actually specify that how many nodes you want. So here in this case, 2 to 8. So the cluster will start with 2 nodes, but then if there is more compute requirement, then it will automatically scale to 8 nodes, depending on what is available in your subscription, right? But if you don't want to do auto scale and have fixed number of worker nodes, then you can have that as well. Now, I don't know how many of you know about Spark, so I'll just touch upon, like, whenever you create a cluster, you have to pick 2 different types of compute. So one is a driver and the other is a worker. So the idea behind the driver is essentially it is managing all the workers. Basically, it is telling the workers that, okay, this is what job request I have got from this application to do some data processing, to do some machine learning training. Go ahead and do this training for me, right? So the workers are the ones which are actually doing the training. So for at least the machine learning service, you can have a small driver, but you should use memory optimized workers. And for automated ML, you need to have at least 2 workers. But if you're not using automated ML and just using Databricks for machine learning, then you can, that is using Spark ML, then you can also have auto scaling. Now, the other feature that is important to know is the auto termination, right? So a lot of times, like, say you have a cluster, and then once you have finished using it, you don't want to pay for it, right? So that is where this inactivity timer comes into picture. So you can say that 60 minutes or 120 minutes of inactivity, it will terminate the cluster. But the good thing is that whenever someone wants to use this cluster again, you don't have to recreate it. So all the data which was persisted to DBFS, and DBFS is the file system on Databricks. So it is, think of it like Azure Blob Storage, right? Or your hard disk, but it is for distributed computing, right? And then you persist. So you basically save that data when the cluster is running on your DBFS or your blob storage or SQL Server, wherever you want to. And then when you restart it, you don't have to redo things. Like, that data is available for you to consume. So that's the good thing about termination. So you are not paying money when you are not using it, but at the same time, when you want to use it, you don't have to redo things. So all the configuration data, as long as it was persisted, is available for you. So this is about creating cluster. And then it takes like 15 minutes or so to create the cluster. So I already have the cluster up and running for this. Now, as you can see, I'm using the latest Spark version over here, 2.4. And I have driver and worker nodes configured. Once you have the cluster running, the thing that you will have to do is to install Azure Machine Learning Service on top of it, right? So, and this procedure is similar for any Python environment. I'm showing you Databricks, but you can pip install the same in other environments as well. So the package is available on PyPy. So you just say Azure ML SDK, and we have two different versions over here. So one is for Databricks, and there is one which is for regular Python environment. So if you are using any other Python environment, like say Azure Notebooks already has it pre-installed, but say for example you are using it locally, for example the Azure Machine Learning Service, then you have to do a pip install this way. So the way you would do it is pip install Azure ML SDK, right? But in Databricks, there is already a library installation option available, so you don't have to do that. You essentially specify just the name of the library. And we have a special library version available for automated ML, and there is another version which is available for non-automated ML. So there are two different library versions available, or the packages. And there are details available on this README. So this is the GitHub which is there. So this will tell you like when to use which one. So essentially, if you are using automated ML, then you use this particular version. If you are not using automated ML, then you can use this particular version, right? But basically, you still have to use one of these two when using Databricks. If you're using DSVM or Azure Notebooks, you don't have to install it. And if you are using any other environment, then essentially you can actually get started even without you prefixing it. And we have all the details available over here in terms of tutorials and how to get started. So this GitHub is there for you to look at. Okay, so now coming back over here, so you just say install, and when you say install, this will install it on the cluster, and you can pick and choose which cluster you want to install it on. So in this case, I already have it installed on my cluster. That's why you see over here installed, and that's it. So this takes a minute or so, but once you have it running, then you can actually go ahead and use any of the Jupyter functionalities that you have, right? So in Databricks itself, like you can create a new notebook over here, and then you can say which cluster you want to run it against, which language. So it has different runtimes. We are using Python, but you can use other runtimes if you want to. But whenever you want to do machine learning training, you have to fall back on Python. But you can interchange the runtimes without having to change the cluster, right? So once you create this notebook, you get this out-of-the-box notebook environment. And then there is the revision history that is maintained. There are comments which you can provide. You can schedule this notebooks to run automatically and things like that. So I'll just delete it. Trash. Okay, and then come back to the example notebooks that I have. Now, all these notebooks that I'm showing are again available in your in the GitHub library, which I showed you. Right, so it's available there, and if anyone wants to look at it, I can actually paste it in the chat window as well. Right, so it's available now. You already have installed this particular SDK in that. The first thing you would do is ensure that the SDK is installed properly, right? So I just attach the cluster over here, and then see the version. Yeah, so it's having the latest version over here, 1.0.6. Now, the first thing you would do when after installing the SDK is to create a workspace. Right, so this workspace is different from the Databricks workspace that I talked about earlier. So this is the Azure Machine Learning Service workspace. The idea behind workspace is to actually, again, this goes back to the point where you are trying to do custom machine learning, and then for end-to-end machine learning, like you are trying to leverage Azure Machine Learning Service to enhance your productivity and simplify your custom machine learning. So in a machine learning workspace, which is a shareable entity, you have all the compute which is there, all the training experiments that you do. So like say if you are running 100 experiments, 200 experiments today, tomorrow, all those things are maintained. Any data store. So what is a data store? Data store is basically a logical pointer to your data source. So there was a question earlier, like which data sources you can use. So say for example, you are using Azure Data Lake Store or Azure Blob Storage, or Cosmos DB. So all these can be logical pointers. So we don't move the data or copy the data to this workspace, but you just define the logical connection and provide the credentials in terms of how to do the connection. Then all the trained models, so this workspace being shareable, like if you want to collaborate within the team, then all the models are available over there. And this image, these are the Docker images basically. So because when you are deploying this machine learning models to create a web service which you can consume, right? You need a deployment environment which is similar to your training environment. So we help you create that. You just specify that, okay, which libraries you want, and we create that environment for you on top of Python or PySpark. You do not have to learn Docker if you don't want to. And I'll show you the code. It's very simple. And then once you have this particular image which is there in the same step, so it's just one method call like deploy from model, and then you deploy it to a Kubernetes cluster. We support two different Kubernetes environment. One is a single node environment which we call as Azure Container Instance or ACI, and the other is AKS, which is Azure Kubernetes Service. And the idea is that this is an auto-scalable production level environment, which you can even deploy it in your own VNet. You can have HTTPS associated with it, and it gets auto-scaled. It supports CPU and GPU as well. So it's all Kubernetes open source based. Okay, and we simplify this deployment part of it. After deploying it, we manage the service for you. So you will see the performance, what is the latency, how many request responses are coming, and things like that. So everything is there, and everything is visible to you in this workspace. And this workspace gets created in your own subscription, right? So I'll show you how to create that workspace. So this is how you create this workspace. You give the subscription ID, resource group, workspace name, and Azure region. You can provide anything what you want. And then you have the actual workspace.create command over here with this. Once it's created, essentially, you will see something like this over here. So, sorry. So something like this. So you can access the workspace not only from the code, Python code, but you can also look at it in the portal over here. And from here, you can actually get started with something else. You want to look at examples. You have any questions, you can post those questions to the forum. And then everything is available in a central place over here. All the experiments, like I said, are available over here. So as time goes by, you might be running multiple experiments. So all those experiments are available over here. And along with those experiments, all the metrics that are there are available, like how much time it took, which are running, failed, things like that. Then you also see the compute that is there. In my case, right now, I don't have a compute. But if you associate a compute, a cluster, then that compute which can be shared across users is available over here. All your trained models are also available over here, right? Once you have it. So this workspace doesn't have that. So let me show you another workspace. We should have different experiments. Yeah, so this has multiple experiments over here. So let me take this example over here. So this is just one run, but if you have multiple runs, like I showed you earlier, you can track the duration. Then all the compute will come over here. And then all the models that you train along the process will show up over here. So let it load. So as you can see, I have different machine learning models and different versions of the same machine learning model. Right, so you can have either of these, right? And then you can pick and choose which model you want to deploy. So for deployment, again, you can use the Python approach, or you can deploy it from portal, or you can deploy it even from VS Code. So in VS Code, Visual Studio Code, basically there is an extension available for Azure Machine Learning Service. And whatever I'm showing you right now, you can do it over there. So if you are a C++ developer, for example, or you are using VS Code for Python, that's fine. You can do that. Okay. Once you have deployed it, with every deployment, there is a Docker image that's created over here, and then all the deployments are available in the particular. So right now, I deleted the deployment just before the demo, but essentially everything will show up over here. And then once you have the deployment, you can actually look at the metrics for that deployment. So this gets in, we have integrated this as part of application insights. So you can look at last 30 days. You can look at server response. So this is basically the Kubernetes deployment. So whatever machine learning model you had, you deploy it as a web service, and then you can look at all the availability and number of unique users, request response, everything. You can also log custom metrics. So if you want to do A/B testing, drift analysis, or things like that, you can do that as part of the deployment. And we will show it to you in your workspaces resource group. So because with every workspace, there is a storage account that is created, right? So this is the resource group of my workspace, and you see the different type of resources which get created. So there's a storage account, there is a container registry, application insight, Key Vault to store your secrets and things like that. So all the metrics that you want to log are stored in this storage account. And if you want to bring in some other storage account, you can also do that. So we give you all the flexibility. Is the concept of the workspace, the Azure Machine Learning Service, what it provides, where to access it, and how is it clear? Are there any questions? Okay, cool. So then let's move on to the next part where essentially I'll show you the actual ingestion, right? So in this case, so the first notebook that you saw was the installation notebook, right? So we ran, we saw how to create the workspace. So this is the prerequisite that you need. The next thing in the end-to-end machine learning process is to do data ingestion over here. So in this case, I'm just downloading the data over here, and this is regular Python code. And then I'm creating a training data set and a test data set. So once I have, and the SDK itself doesn't have a role to play over here, you would use your regular pandas or PySpark approach for doing data preparation in this case. But we also support a data prep SDK. So it has certain benefits, and I'll touch upon it when I show you automated ML. Now, once you have your training and test data set available, you actually are ready to do the machine learning training, right? So in this case, I'm still not showing the automated machine learning. I'm showing the manual machine learning and how you use the Azure ML SDK as part of it. So you get the workspace detail that you had, and then you define the model. So in this case, I'm using logistic regression. You could use something else. I'm running multiple iterations of the model, and then I'm logging each iteration using the SDK. So there's a run.log method which is there, and you can log any metric. So in fact, anything that is a key value pair can be logged over here. You can even log your name, because that way you can find out that, okay, who ran this experiment, right? So when you log all this with every iteration, that same thing is available in your workspace. And you can again retrieve it from within the Python SDK or even in the portal over here. So I'm using a previous experiment run just to showcase, like whatever tracked metrics are there. There are child runs with each. So say for example, I have 4 different iterations. With each iteration, I have logged the parameters which are there, right? And it is also logging the metric, which is the outcome of the experiment. So not only the input parameters, but also the output parameters. So this way I can revisit back in time and see that, okay, I got like 95% accuracy on this particular day. What is it that I did, right? So you can log all these parameters. And the other thing is that if these parameters are in a sequence or a step, then we actually give you a chart. So that's the one which I was showing earlier. So let me go back, show this experiment. So here, it's the pipeline, for example. Yeah, so you see over here, we create a chart for you, and then you can actually go into any of these runs, for example. And then you can see all the metrics which are associated with it. So ROC, gain curve, or things, anything. So basically, whatever you log, you can actually show in your workspace and retain it for future. Okay, and that's how it will work. So there's a question. Is this notebooks where we are referring the algorithms? Yes. I should say answer live. Okay, I don't know. I haven't used this. But essentially, the notebook is where you are running the algorithm, right? And when you are running this notebook, you are actually using the underlying compute, because every time you use a particular algorithm, you need a training compute underlying it, right? So you use that. And the Azure Machine Learning SDK provides you with the capability to have the compute and run any algorithm on top of it. So think of it like if you are using C++ or C#, Python, I don't know which all languages you use. I think I can poll it later. Probably I should have polled in the beginning, but basically you write code in your IDE like Visual Studio or any other IDE. Similar to that, you are writing code over here in the notebook. But this environment is interactive, right? So essentially when I go here, let me go back again over here and run this. So I can do a run all, or I can click on any cell and do a shift enter, right? So the reason I want a notebook where I have provided the parameters. Yes, this one should have all the parameters which are there. Yes, so you see over here, so if I do a run all, it will attach to the cluster. So it is going, it attached to the cluster which we created, right? Now it is running the cells one by one, but I did a run all. Instead of that, you can do a shift enter. And if you do a shift enter, then also it will work. So that's how it's similar to Jupyter, right? I authenticate it over here. So the reason we are authenticating is making sure that whosoever is running this code has the permission to run it. And in this case, we are using Azure AD. So I'm just authenticating against Azure, right? So the subscription that I'm running it against, I have the permission for it. And then what it does, it's going to say that authentication successful, right? So it says authentication successful. So each cell is running one by one. So that's the difference, right? And then you can see all the details. So this is the workspace that I showed you just now, right? Once the workspace is created, then I can go to the next notebook where I am running the next set of code. So I can do again a run all, or again run cells one by one. And then while it is running, I can go to the next notebook. So that's the beauty of Databricks environment, that you don't need to have a computer running in order to just read that, right? So once you have this, let me show you what algorithms I'm running. Yeah. So every time I run the algorithm, I'm changing the parameters, and this way I'm trying to find out that, okay, which algorithm and which parameters are best for me. And then I go to either I go to the portal or I use Python code to find out that, okay, give me the best algorithm which has the maximum metrics over here. So that's how I will run it. Is there a question for this demo? What is the data source? In this case, I'm copying data from a blob storage. So basically, these are CSV files, and these CSV files are over here. But you can bring in any data source as long as you can define it somewhere. So if you see over here, I'm downloading the CSV from a blob storage and then creating a train and test data set. But instead of that, if you have any other data source, it's absolutely fine. You have to just create a data frame from your data. So that's the only prerequisite, right? So you create a data frame, because that's how machine learning algorithms work. And you provide this data frame to this. So in this particular experiment, I'm trying to do income prediction. So I have adult income data set, which is demographic data. And then based on this data set, I'm trying to predict whether the income is greater than $50,000 or less than $50,000. So that's my data set. Okay. Are there any other questions? Yeah, all good questions. So thank you for that. Then once I have trained a particular model, what I am doing is I'm actually deploying it to the cloud. So if you see my previous notebook, which was notebook number 3, where I'm training the model, right? I got a particular model over here, which was giving me the maximum metrics, and I'm saving that model to my file system over here. So I'm doing save, right? So I'm saving that model over here, and then I'm reading that model in the next step. So the idea is you train the model either within the same environment, or you bring in a model from any other external environment, but you can still use the Azure Machine Learning SDK to deploy it, and the deployment as a web service or a batch, and then we'll manage it for you. So the prerequisite for deploying or using this is basically you register the model in the workspace. So over here, like whatever models you see over here, these are all registered models, because you might be training hundreds of models, but you want to register only the ones which you are interested in deploying, right? So you register the model, you provide a scoring file. Now, what is a scoring file? A scoring file is basically having an init and a run method. And this is how we will know what you want to do with this model. So init is initializing it, and run is actually when you get the data, what is it that you want to do with that data. So you provide the scoring file, right? And then that's it. You say that, okay, I want to deploy it in a Kubernetes cluster with this many nodes, or I want to dev test it with Azure Container Instance, and we'll create that environment for you and deploy it. Meanwhile, I saw questions, so let me see. Done. When you click run all in the workspace, it will create an experiment or create a model. So run all is basically just running all the cells that you see over here. So it is actually not creating or doing. So that this run all can be data ingestion, or it could be something. So in this case, say for example, instead of run all, I can do a shift enter over here, right? So it is running whatever is there in this cell over here. And similarly, you have run cell over here. So that's basically what is happening. The only thing I did run all was it is running all the cells in this particular notebook. So I don't have to individually run each and every cell. So that is why I did a run all. So that's more of a, that behavior is independent of whether you use Azure Databricks or Azure Machine Learning, like even in Jupyter or even in Azure Notebooks, you will see the same approach. So because this is basically interactive execution. So you are individually running each and every cell. Okay, so that's the idea behind this. Now, for the deployment part, you provide this Kubernetes environment. And in this Kubernetes environment, you specify how many nodes you want, what is the runtime, is it like a Python or PySpark, and then you deploy the web service. Once you have the web service, you have this particular kind of an HTTP API. And this API is basically where you will be sending data, which is in this case JSON data for prediction, right? So now your machine learning model, so the machine learning model in our case is predicting the income, that is now available as a web service. So now as an AI developer or anyone, business analyst or whosoever wants to use this web service, he or she doesn't need to know machine learning. They are just sending this data to this endpoint and getting the prediction. So in this case, I'm running this, I'm sending 5 different rows of data and then getting a prediction whether the income is greater than 50K or less than 50K. So less than 50K is 0, greater than 50K is 1. And then when I don't want to use the web service, I just do a delete. You can do all these things from the Python notebook, or you can do all those things from the portal as well, right? Or any other Python. So this is the whole end-to-end machine learning part. So we have 18 minutes. So let me jump into this part so you have an idea in terms of what I showed you. So what we did was we created a Databricks cluster. You can use any other Python environment. We created a data set. We had, in this case, it was an income prediction data set. We created a train and test data, right? And then we used few machine learning algorithms. We created a machine learning model. And then we wanted to create a web service out of that model so that others can use that model, right? So in order to create the web service, we registered the model using Azure Machine Learning SDK to the workspace. there was a Docker image that was created by the service for you. It was stored in your subscription, and then we deployed it as a scalable service, right? So in all this, we did a manual approach. Now I'll show you the training part where you use the automated ML approach. So everything else remains the same. The only thing that changes is the automated ML part. So when using automated ML, the idea is that you provide a data set, you provide the type of experiment, and you provide the constraints. Like, you don't have to worry about like which algorithm to use and things like that, but you do have to worry about how much training time you want to give. So say for example, you want to run the training for 6 hours, then you have to tell us that run this for 360 minutes and give me the best algorithm from within this 360 minutes, right? Algorithm and a set of parameters. So that's the thing. And then you have to specify that what metric you are trying to optimize. So be it increasing the accuracy or decreasing the error, and that's it. So we take care rest of the things for you. And the way you would do it is so again, these are the same. This is the same workspace that we had earlier, right? So you can reuse the same workspace or create a new one. And then the only thing you would need to do is load your data set, right? So this is where we use something called deprep, and the deprep part is it auto reads, it figures out the headers, or you can skip the header. It figures out which columns are string, which columns are numbers, right? And then we actually pre-process the data for you. So like I said earlier, many algorithms require numbers. So if we see a string over there, then you can actually say pre-process equal to true, and then we will convert that string into numbers. And the parameters which the experiment takes, or the config that you have to provide, are something like this. So you have to specify whether it's a classification or regression. So right now we support only classification and regression, but in the next few months we are looking at clustering and many other approaches or use cases. You specify the metric that you want, right? You specify the timeout, and then if you are using Databricks, then you have to just give the Spark context. The default context is SC, the iterations, and then your data set. So this is what you have to provide over here. Let me scroll up. So this is what you have to provide over here, and that's it. So you see, I did not specify that I want to use logistic regression. I did not specify which parameters I want to use, which is what we did in the earlier manual approach, right? We just specify this config, and then we run it. So once it is running, and it takes a few minutes, so I already have a pre-run available over here, but it goes through. So in this case, I specified number of iterations as 30. So it is going to find out the 30 best algorithms, and then give you like which pipeline is the best for you in terms of the parameters and the algorithm itself, right? So and you can navigate, you can look at every algorithm which is there, how much time it took, the metric which is there in Python in the notebook, or you can look at it even in your workspace. And I already showed you this earlier. So this was the same training. So there's a setup run and there's actual pipeline. That's why you see pipeline over here. And you can, if there are some outputs, you will see over there. There are some logs you can see over there. And you can download this entire pipeline as a snapshot. So you can actually dig in deeper. But everything is available over here. And then you can actually look at an individual run and what are the metrics associated with that run. Or you can just look at summary of each run over here, like what was there. So this is basically automated ML. And then you can query this run based on any metric. So even though you optimize it for one particular metric, you want to query it for another metric, you can do that, and you can train it. And then once you have your pipeline available, you can actually again deploy it to a Kubernetes cluster. So it can be again deployed to ACI or AKS in exactly the same way. So the workflow remains the same, except that we have simplified the training part for you. So this concludes the talking part. I was talking for more than an hour now. So I saw one question, I think. Chat. Okay, let's see. 15 minutes to go. Okay, yeah, I think I'm done. So are there any questions, summary, how did you find it? If people can put it on chat, Q&A. And I don't know how to do a poll. Rohit or someone can, if you can help me create a poll. I don't know how you gather the feedback or the audience and things like that, but I'll be interested in trying to find out like how many of you are actually trying to use or going to use this after this session, and what are your use cases. So there are these notebooks available, so these links are available for you, and of course you can reach out to me as well, or any of the forums that are there in order to find out your use case. So
yes,
I
Parashar,
would
people can put their answers in chat window also, or else if you give me 1 minute, I'll just create a poll also. That's also fine.
yeah, poll is fine. I have time, so we have 12 minutes. So yeah.
So can you type speak out the question, then I'll just type it.
Yeah, so I want to know like how many users are data scientists, AI developers, how many users find this useful and going to try it out immediately. And the question which is there that yes, Python is required because this is targeted for custom machine learning, but we do have other offerings where you don't need to do Python. I mean, I don't work on that, but of course you can go to Azure AI and then search for it. So one is Azure ML Studio, which is there where you don't need to know Python. But whatever I showed today are all custom machine learning where Python is required. If you know C#, then also we have actually ML.NET. So that is there. So if you have interest, then reach out to me and I'll connect you with the appropriate product manager, and he can actually give you more details on that. Can we use RStudio? RStudio, no, because the SDK supports R. Doesn't support R right now. It supports Python. But you can use RStudio with Databricks. So there are two parts, right? So if you are an R user and still want to do machine learning, then you can use Databricks with R, but you will miss out on the Azure Machine Learning service benefits that I actually talked about. Okay, so thank you for creating the poll. Just done. So how many users are going to try it out? Of course, I'm going to say yes. Oh, I cannot answer. Okay.
You cannot answer.
Okay. Could you? Yeah, I can actually type it. So the best way to reach out to us is like if you use MSDN or things like that, because my email, even though you have it, I won't be able to scale, but I can type my Twitter or yeah. So let me type my Twitter at Parashar. So I assume people can see it. I don't know. If not, I'll just type it over here. But that's my Twitter, and the best way to reach out to us is like if you go in like anytime you create this workspace, right? You see this live forums over here, so you can actually go here. That's our forum. So we are like 35 product managers, and the team is like 800 plus. So it's a vast team, and because we have so many things going on. So best is to reach out to us from here. You ask a question, and this is being monitored all the time. So anything you have, you just sign in and ask the question, and one of the PMs will actually get back to you. So I think that's the fastest way to reach us. Okay.
81%, yes.
Oh, 81% are going to use it. That's great. Thank you. Yes. The other is the AI developer versus data scientist. If you could ask that one as well. So.
Yes.
I'm a BI developer, but I want to learn machine learning using Python. Okay, so good. So if the question is like, how do I get started with Python? So we have a lot of resources. So let me show you. So we have a free program. It's a free program called Data Science Professional Program. It's called Microsoft. Yeah, this one. Academy. Yeah, so I'll post the link over there. So this is in collaboration with edX, edx.org. And these are step-by-step courses. So like it can take anywhere from 4 months to 9 months to complete it. but it will teach you all the basics of Python and machine learning. Now, whatever I showed you may not be available on the track. So it might show you some other things, because whatever I showed you was like general availability 2 months back. So it's kind of the latest offering that we have right now. So these courses will get updated in a month or two, and after that you will have that. But until then, if you are trying to learn Python itself, then I personally think this is the best way. And in fact, like you see over here, there is an option to learn R as well. My preference is Python, because I know Python, I don't know R. But yeah, if you are using R, then also there are tracks which give you an option. So it will teach you how to do data exploration and training. So this is one course, but then there are other tracks over here. So there's a big data track, and I think there is something for even Databricks, which is there. So that's how it is. Is there any other chat or question? Will you share this presentation? Yes, in fact, the presentation is available I gave a public presentation as well. So all the links are there, and this is recorded already, right? So that is there, but let me post it now.
You can share the deck with us. So we are going to upload that in our DataPlatformGeeks website. From there, they can download.
Okay, yeah, so that's also fine.
So you can share the deck and necessary resources with us with Rohit. Then he'll update that DataPlatformGeeks website.
Okay, yeah, I can do that. But just want to show you that this is not the same session, because what I gave was a very long 1.5 hour session right now today. But I did a 25 minutes or another session during one of the annual conferences recently, and that is there on YouTube. So I'll give you that. But independent of even if you don't want to wait for the PPT or things like that, whatever I showed you is documented over here. So I'm going to paste this URLs over here again, just in case someone missed it. So everything is available over here. We have actually videos. So these are all the notebooks. So everything, all the demo and everything I showed you, README, how to create the cluster, everything is available here. This is our documentation, like how to get started. And there are videos. In fact, I also have created a couple of videos which you can go through that. There are sample notebooks to get you started, how-to guides, tutorials, step-by-step. So everything is very well documented for you to get started with. So even independent of whether you get the presentation or not, you have everything. Okay. So including like getting started with Python and yeah, so there are these 5-minute videos in terms of installation, deployment, and everything. I saw one more question.
So before we close, Rohit has few slides to show up, so he'll take it from now, and then we can continue after that.
Yeah, so this is the recommended approach. Okay, so what was the poll result? I think I'll just stop sharing. The data scientist versus AI.
Yes. So 68% people voted. Out of that, 64 are data scientists and 36% are AI devs.
Awesome. That's good. And 80% want to try it. So I look forward to working with whosoever wants to try it. That's great. Thank you.
Sure. Rohit, you can take it ahead from now.
Wonderful. Thanks a lot, Parashar. That was a very informative session, 90 minutes. All right. Like I said earlier, we have Facebook, LinkedIn, and Telegram groups where you can ask all the technical questions. Some of our DPG speakers are also there. So you can go ahead and join these groups and ask your questions. We have a lot of learning solutions at SQLMaestros. We have the master classes coming up. This time it's going to be online master classes, and we have announced 12 of them on a Microsoft data stack, including SQL Server, SSRS, Power BI, machine learning, Python, R, and a lot of other stuff. So, and this will be taken by world-renowned experts starting from Jan end. So you can go ahead and check out all of them at our official SQLMaestros website, that is SQLMaestros.com, and you can register right away. We have the SQL Server Performance Tuning course. It is coming out as a video course this time by Amit Bansal. This is a very popular training course, now available as a video format. And if you register right away, you get a chance of 50% discount on the regular price. So, and we also have the famous hands-on labs where you can do it yourself. You can practice step by step all by yourself. Since you're a DPG member, you can access some of it for free. So go ahead and you can visit DataPlatformGeeks.com, go to hands-on labs section and access our demos. We are working on learning kits that will be out soon, so look forward to that. And in case you have a SQL Server health check requirement, you can always again write to contact@SQLMaestros.com. So that's it. I'm done. And once again, thank you all for joining. And I would like to tell you that we have participation from 11 countries for today's webinar. And I think that is wonderful. And thank you, Parashar, for taking time out for delivering this 90-minute session. Thanks a lot. And just before I forget, we will be taking this webinar pic of this and uploading it on our groups, where you can give your feedback for the session, where the speaker, Parashar, can also have a look at it, and we will send him the feedback too. So you can go ahead, excuse me. So you can go ahead and give your feedback there. And we also have Joe Sack giving a webinar day after tomorrow, same time from 9 to 10:30 p.m. So if you have not registered already, go ahead and register. And like I mentioned earlier, Feb 2, we will be having the official launch of Data Platform Summit. And also, this will be our first multi-track event. So do not miss that. It is in Bengaluru, Microsoft office. Do not forget to register. So with that, I'm signing out. Parashar, you can take over if you have any questions left. Thank you so much.
No, I think this was great. Thank you. And I look forward to people using it and interacting, and look forward to the feedback as well. So thank you very much.
Sure. Thank you.
One last thing, I think I don't know if I can, but there is a book also which I've written. If you search on Amazon with Parashar Shah, you should see that it has bits and pieces of whatever I talked about. So yeah, just in case if anyone is interested to dig in further. Yeah. It's called Hands-on Machine Learning with Azure. So,
I just typed that book name in the chat window, Hands-on Machine Learning with Azure.
Yeah. Thank you very much. Cool. So, goodbye, everyone.
So thank you, Parashar. Thank you for joining, and thank you all for joining today's webinar, and looking forward for all of you to join day after tomorrow as well. So good night for Indian audience, and elsewhere, good afternoon and good morning, maybe. Thank you.